Yo, what's going on, guys? All right, making a video on another Regents question. This question here is mainly testing this topic, rational powers and laws of exponents, okay? Specifically raising a power to a power. I should also add, uh, yeah, just these things, okay? So like rational powers represent radicals, right? And vice versa. So radicals can be also expressed as rational powers, okay? Um, yeah. Okay, so let's start. So read this question, pause the video, and yeah. Okay. So for n and p greater than 0, they're asking, is this expression here equivalent or equal to this one here? Justify your answer. Okay. So there are a few ways of doing this, right? But they're all like very similar. And the heart of this problem is just, can you make this thing look like this somehow? Okay. Or another way is like, can you simplify this one using equivalent steps so that it looks like something else? And then do the same with this so that it looks like something else. And then those two something else's look the same. Okay. This thing here, this is also interesting, but this is kind of like beyond the scope of this this class. It's talking more about like domains and stuff. It's a good exercise to try. Okay, but yeah, I'll come back to this at the end. Okay, so this. Here, square root of p. Let me change this. Geez. Okay, square root of p. That's equivalent to saying p to the half. Okay, and that's have this in mind. It's it's useful. Okay, and then this thing, right? If you know that this is the same as saying square root of 2, which is the same as saying the second root of a number like this. This is the same as saying this. You can apply this here. So if you do this, you're going to get you can rewrite this as p5 to n to the 4th parentheses to the half, and then p squared n to the half to the 8th, right? But this power, oh, there's so many pinks here, geez. This power here, right? You have this is the base and this is the power. When you see this, you can just distribute the powers to each factor in here in the base. Okay, so here it's p squared, so you do 8 times 2, so this is going to be p to the 16, and then n raised to the half times 8, right? So half times 8 like this, but that's just the same as saying 4. Okay, so you have this in parentheses here, and then same thing here, you distribute the half in here, p to the 5 halves, and then n to the 4 halves. Okay, this is the same as saying 4 over 2 is the same as saying n squared. So you have p 5 over 5 halves times p16 to the n to the 4th. You can drop these parentheses, right? Because it's like it's associative property of multiplication, so you can kind of group them however you want, right? So let me drop these and just know that these are all times anyway. Okay. Notice that there are some same base terms here. I don't want to say like terms, because when you say like terms, that's like associated with plus and minus, and this is just multiplication once again. Okay. So here, commutative property, I can move this here so you can multiply these p's and gather up the p's, right? And this is where this comes in. Multiplying powers with the same base, then you just keep the same base, so p, and just add the exponent. So it's going to be 16 plus 5 halves. Okay, and that's just going to be you could change this to 32 over 2. This is going to be 37 halves. All right, and then similarly you could do the same with these terms, n to the 4th and n squared. So that's going to be n to the 4 plus 2, right, which is just n to the 6th. So all of this thing is just this. Okay, and we still need to see if it equals this thing. Okay, so this is the thing where changing this to p to the half is convenient. Okay, because if you know that this is p to the half and this is p to the 18, then you can combine these p terms again, and you're going to get p to the 18 plus a half. That's p to the 18 and a half. But if you want to as an improper fraction, that's going to be 37 halves. Okay. So this is like saying p to the 37 halves times n to the 6, right? And these are equivalent here. Okay. So because that these are the same, we say that the answer is going to be yes, they are. And oftentimes in the Regents, when they justify this math work suffices. Okay, but if you want to explain, saying all of this extra stuff that I said, then that's fine too. Another path you could have gone, if you knew, there's like slight variations of this, right? Like you can, in this step here, this 37 halves, you could take out the half, right? And so that's going to be p to the 36 over 2 times p to the half. And then that's square root of p, and then make that look like this without, changing this, because that's what we did here. We changed this to look like this, and this is equivalent, and yeah. Okay, and then, yeah, that's it. And as a nice little exercise, not related to this topic, you should think about why this thing is necessary. This is more useful for a higher level math and like for like the theory and stuff. It's like testing domains of the domain of discourse and like of statements and whatnot. Okay, cool. All right. This is hella sloppy. I'm chewing gum here, so it's kind of like really poor ASMR, but it's all good. Had to make this video before going to bed, so yeah. All right, guys, take care and be good.